Inuggit's Robotics STEM Academy isn't just another Intro to Robotics boot camp. It's the only program, college level or otherwise, that has solved one of the most overlooked pain points in robotics education: how to teach inverse kinematics in a way that's structured, practical, and deployable directly to hardware. Why struggle through bloated frameworks like ROS, ROS2, Julia, MATLAB, or Simulink when someone can hand you the answer? That's exactly what Inuggits delivers: a clear, repeatable method for solving inverse kinematics using the Denevitt-Hartenberg convention, a gold standard in both industry and academia. But we go further. At Inuggits, students learn to program directly to the hardware, bypassing the need for middleware or simulation tools. This isn't just theory, it's execution. And it's the kind of skill that makes you stand out in a crowd of coders and classroom learners. Even robotics innovator Jacob Leander emphasized that inverse kinematics is the way to go.
After hours of digging through YouTube videos and articles, I realized inverse kinematics was the best answer. But most tutorials I found were either too complicated, too vague, or only explained a single leg. So in this video, I'm making the guide I really wish existed when I started on my own. I'll show you how to implement inverse kinematics using simple math and easy to follow code. No advanced math degree required. We'll use my hexapod here as an example, but the same principles apply to any legged robot or even robotic arms. And once you understand the basics, you will be able to create really smooth, complex movements with just a few lines of code. So let's get started.
Even with standout resources like Jacob Leander's Master Inverse Kinematics for Robots, many still find themselves stuck when it's time to implement the concepts. That's exactly why I wrote Robot Kinematics Demystified. This guide breaks down inverse kinematics using the proven Denevitt-Hartenberg convention, a systematic, hands-on approach that makes complex math accessible, even for beginners. It's the resource Jacob wished existed when he started. Now it does. Pre-order today at 50% off the original price. Limited time only.
Watch his breakdown, We Agree, and we've built a curriculum that teaches it from the ground up, using math, logic, and hands-on deployment. By the end of the course, students walk away with the confidence to apply these skills across any math or software discipline. They don't just understand robotics, they embody it. And yes, you'll impress your parents, peers, and teachers just like Mark Zuckerberg did in The Social Network.
I see we have our first surrender. Don't worry, Mr. Zuckerberg. Brighter men than you have tried and failed this class.
One valid bit, one modified bit, one reference bit, 5 permission bits.
That is correct. Does everybody see how we got there?
Watch the moment part 1 of our series on modeling Otto's DIY biped robot using kinematic equations. Part 2, the programming walkthrough, will be available exclusively to our private community. Because while theory is everywhere, execution is what sets you apart.